In the United States, 1 in every 5 women will be raped in their lifetime, and a rape is reported about once every 5 minutes. 4 decades ago, before genetic engineering became an accessible tool in criminal investigations, the techniques used were quite rudimentary. In the year of 1983, these techniques fell into the background because a new one was developed by Kary Mullis, a Nobel Prize winner biochemist. Polymerase chain reaction, PCR, became the go-to way of finding evidence to convict felons. Laboratories, hired by police departments and defense attorneys alike, began to use this technique followed by gel electrophoresis to identify and convict criminals. Polymerase chain reaction is a technique used in laboratories to make many copies of a specific part of a DNA sample.
Gel electrophoresis is a technique used to separate DNA strands based on their size by loading them into a charged gel. The strands will move from the negative end to the positive since they are made of negatively charged molecules. Because they are of different sizes and charges, the strands will move in different speeds, allowing them to be separated from one another. PCR and gel electrophoresis used in the context of criminal investigations became known as the DNA fingerprinting technique, which is used to establish a link between biological evidence and a suspect in a criminal investigation. This technique is now widely used for its accuracy, ability to give quick results, and accessibility.
In the year 1987, serial rapist Tommy Lee Andrews was the first American to be ever convicted in a case involving DNA profiling, or in other words, DNA fingerprinting. He was accused of raping almost 23 women in the span of 2 years.
Prior to DNA testing, labs were limited regarding the amount of genetic information that could be obtained from the semen. Now with DNA profiling, the genetic content of the sperm itself can be examined. Police sent 2 samples to a New York laboratory for testing semen left at the crime scene by the rapist and blood taken from Andrews. The laboratory isolated DNA from each sample using PCR, then compared the 2 and found they matched. The lab couldn't match Andrews' entire genetic code to the rapist's, since that would be technically impossible. However, technicians could compare representative pieces of the 2 DNA samples that scientists know are highly variable in the human population. It is not unusual for 2 randomly selected people to have the same DNA pattern in one of those genetic locations, known as variable number tandem repeats. However, it is rare for unrelated people to share the same DNA in 2 such areas.
Because Tommy Lee Andrews could not be convicted based on the little evidence that they had, authority decided to resort to something more substantial. In this case, DNA profiling, more specifically, PCR and gel electrophoresis.
It was also due to the fact that DNA profiling at that time was only introduced about 5 years ago and was deemed to be a more accurate method.
The state of Florida in the United States hired a private lab to test evidence in Andrews' cases, and the DNA matched.
An expert in genetics analysis had testified that the DNA fingerprint of Tommy Lee Andrews' blood matched that of the rapist's semen. Michael Baird, a senior scientist at Life Codes, and David Hausman, a research biologist at the Massachusetts Institute of Technology, testified that the DNA in the semen and in Mr. Andrews' blood matched.
Another milestone for the use of DNA fingerprinting in criminal courts, and genetic engineering for that matter, was in the trial of Timothy Wilson Spencer in 1988. In fact, he was the first person to be sentenced to death on the basis of DNA evidence. Spencer was a suspect of raping and murdering 4 women, but the leading detective in the case, Joe Horgas, does not have enough evidence to arrest him. Although he found a link between the time and place of the rapes and Spencer's activities, this was not enough to get him convicted. therefore they resorted to DNA fingerprinting to find the evidence they needed to put him behind bars. They sent a sample of Spencer's DNA and the semen collected from the bedclothes at the crime scene to a laboratory called Life Codes Corporation to perform DNA analysis. The results of this analysis established that the DNA from Spencer's blood matched the DNA from the semen stains, and during trial, 7 scientists examined the results and considered it conclusive. These results not only proved Spencer guilty, but also exonerated an innocent man, David Vasquez, who had been arrested prior to Spencer's trial because the police believed him to be the serial rapist. The use of DNA fingerprinting to solve rape cases benefits the victim, but also society as a whole, because it increases the likelihood of identifying the perpetrator and holding them accountable, and also prevents future sexual assault from happening when dealing with serial rapists. However, the widespread use of this technique also gives rise to some ethical issues. The fact that DNA is one of the main ways to identify rapists may lead to the reinforcement of the idea that violence is genetic. Forensic doctors may start to identify patterns in the DNA of criminals and thus start concluding that there are genes that make you violent.
Moreover, reopening a case due to improved techniques and DNA evidence being retested for the sake of solving unresolved crimes might not be what the victims want. Some victims prefer to leave these traumatic experiences in the past and move on, and reopening an investigation may ignite psychological distress and, in some cases, PTSD episodes. And finally, with an increasingly demand for DNA evidence to be part of rape investigations, governments have become more serious about collecting DNA samples from citizens in order to increase their DNA database. For example, CODIS in the US.
Some may see this as invasion of privacy, since DNA can be used to track down relatives and to gather information on a person's race, to form a psychological profile, to analyze susceptibility to diseases, and even to monitor our movements. In conclusion, genetic engineering, although permeated by controversies, not only contributes to agricultural advancements and to identifying disease-prone genes, it is also an essential tool that can be used to help bring justice to unresolved cases, to prove innocent wrongfully convicted persons, and to hopefully diminish the amount of rape cases that go unsolved.